For an ungrounded separately derived system, Article 250.30 does not provide guidance for sizing the equipment bonding jumper for the secondary side. Instead, the equipment bonding jumper must be sized in accordance with 250.102c. This section of the National Electrical Code provides specific requirements for determining the appropriate size of the equipment bonding jumper based on the size of the unbranded conductors. Understanding how to properly size this conductor is crucial for ensuring electrical safety and compliance with the code. The equipment bonding jumper plays a vital role in providing a low impedance path for fault current, facilitating the operation of overcurrent protective devices. To correctly size the equipment bonding jumper, refer to Table 250.102 Kern. This table correlates the size of the ungrounded conductors to the required minimum size of the bonding jumper. The ungrounded conductors are also known as phase conductors or hot conductors. They carry the electrical current from the source to the load. For example, if the ungrounded conductors are size 3/0 American wire gauge copper, then according to Table 250.102 Kern, the equipment bonding jumper must be at least size 2 American wire gauge copper. It's important to note that this is the minimum size requirement, and a larger size may be necessary depending on specific installation conditions or engineering design considerations. The table provides sizing for copper, aluminum, and copper-clad aluminum conductors. Be sure to choose the correct column based on the material of the conductors you are using. When selecting the appropriate conductor size from Table 250.102 Kern, pay careful attention to the ampacity of the ungrounded conductors as well as the requirements in 250.102c. If the ungrounded conductors are larger than those listed in Table 250.102 Kern, then 250.102 Kern instructs you to size the equipment bonding jumper not less than 12.5% of the area of the largest ungrounded conductor or equivalent area for parallel conductors. This calculation ensures that the bonding jumper is adequately sized to handle potential fault currents. If the separately derived system supplies fire pumps, the equipment bonding jumper shall not be smaller than the size indicated in 695.6c. The requirements for fire pump systems are more stringent due to the critical nature of their operation during emergencies. Always consult Article 695 for specific details related to fire pump installations. The equipment bonding jumper connects the equipment grounding system to the separately derived system's grounded conductor, or the metal enclosure if the system is ungrounded. This connection ensures that all metal parts of the electrical system are at the same electrical potential, minimizing the risk of electric shock. Proper installation of the equipment bonding jumper is just as important as selecting the correct size. Ensure that the jumper is securely connected to both the equipment grounding system and the separately derived system. Use appropriate connectors and hardware to maintain a low impedance connection. Inspect all connections to verify they are tight and free of corrosion. Corrosion can increase the resistance of the connection, reducing its effectiveness in carrying fault current. Consider using antioxidant compounds on aluminum connections to prevent corrosion. Always refer to the manufacturer's instructions for proper installation techniques and torque specifications. Proper torque is essential for maintaining a secure and reliable connection. Under-torquing can lead to loose connections, while over-torquing can damage the connector or conductor. In addition to 250.102c, other sections of the National Electrical Code may influence the sizing and installation of equipment bonding jumpers. Always review the entire Article 250 grounding and bonding to ensure a complete understanding of the applicable requirements. Specific applications, such as healthcare facilities or industrial installations, may have additional requirements. These specialized installations often have unique grounding and bonding considerations to address specific safety concerns. When working with electrical systems, always prioritize safety. To energize the circuit before making any connections or performing any work. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to work on electrical systems, seek the assistance of a licensed electrician. Electrical work can be dangerous, and it is important to have the necessary knowledge and skills to perform the work safely. Incorrectly sized or installed equipment bonding jumpers can have serious consequences. In the event of a ground fault, an undersized jumper may not be able to carry the fault current, leading to a delayed or failed operation of the overcurrent protective device. This can result in equipment damage, fire, or electric shock. Therefore, it is essential to follow the code requirements and ensure that the equipment bonding jumper is properly sized and installed. Remember that the National Electrical Code is updated regularly. Stay current with the latest edition to ensure that you are following the most up-to-date requirements. Changes to the code can impact the sizing and installation of equipment bonding jumpers. Continuing education courses and industry publications can help you stay informed about code updates and best practices. In summary, to size the equipment bonding jumper for an ungrounded separately derived system, refer to 250.102c. Use Table 250.102 code to determine the minimum size based on the size of the ungrounded conductors. Ensure that the jumper is properly installed and connected. Prioritize safety and consult the latest edition of the National Electrical Code. Understanding and applying these principles will help you ensure the safety and reliability of electrical systems. Also, it is important to remember that the equipment bonding jumper ensures a low impedance path, which means that it must allow a large amount of current to flow through it when there is an electrical fault. This low impedance path is what allows the overcurrent protective devices such as circuit breakers or fuses to quickly trip and clear the fault. If the equipment bonding jumper is not properly sized or installed, it can create a high impedance path which can impede the flow of fault current and prevent the overcurrent protective devices from operating correctly. In addition to the size of the ungrounded conductors, other factors can affect the required size of the equipment bonding jumper. These factors may include the length of the jumper, the type of conductors used, and the presence of any other grounding or bonding connections. It is important to consider all of these factors when determining the appropriate size of the equipment bonding jumper. Another important consideration is the material of the equipment bonding jumper. Copper and aluminum are the two most common materials used for equipment bonding jumpers. Copper is a better conductor of electricity than aluminum, so it generally requires a smaller conductor size for the same ampacity. However, aluminum is less expensive than copper, so it may be a more cost-effective option in some cases. If you choose to use an aluminum equipment bonding jumper, be sure to select a conductor size that is appropriate for the ampacity and the application. Also, it's important to use connectors that are specifically designed for use with aluminum conductors to prevent corrosion. Keep in mind the function of an equipment bonding jumper. It serves as a vital safety component in electrical systems. Its primary role is to provide a low impedance path for fault currents, facilitating the rapid operation of overcurrent protective devices like circuit breakers or fuses. This quick response is crucial in preventing electrical shocks, fires, and equipment damage. By connecting non-current carrying metal parts of equipment and enclosures to the grounding system, the equipment bonding jumper ensures that these parts remain at or near ground potential. This minimizes the risk of dangerous voltage differences that could pose a hazard to people who come into contact with the equipment. Moreover, the equipment bonding jumper helps to reduce electrical noise and interference, which can improve the performance and reliability of sensitive electronic equipment. Properly sized and installed equipment bonding jumpers are essential for maintaining a safe and reliable electrical system. Ignoring or neglecting this component can have serious consequences, including electrical hazards and equipment failures. Therefore, it is crucial to adhere to the National Electrical Code requirements and best practices when selecting, installing, and maintaining equipment bonding jumpers. The National Electrical Code provides guidelines for the proper sizing and installation of equipment bonding jumpers. These guidelines are based on factors such as the size of the ungrounded conductors, the type of equipment being served, and the overall grounding system design. It is important to consult the NEC and other relevant standards to ensure that equipment bonding jumpers are installed in accordance with applicable requirements. Furthermore, qualified electrical professionals should perform all electrical work, including the installation and maintenance of equipment bonding jumpers. These professionals have the training and experience to ensure that the work is performed safely and in compliance with applicable codes and standards. Remember that electrical safety is paramount. By following the NEC guidelines and relying on qualified professionals, you can help to ensure that electrical systems are safe, reliable, and compliant with applicable regulations. If you are not familiar with the NEC or other electrical codes, it is important to seek guidance from a qualified electrical professional. Attempting to perform electrical work without the proper knowledge and training can be dangerous and may result in serious injury or property damage. Therefore, it is always best to err on the side of caution and consult with a qualified expert before undertaking any electrical project.